learning the representative expression for the equivalent of the Laplace transform of t, which is 1 over s squared. We can now come up with another form for the Laplace transform of t squared. We are going to still use the same expression for the Laplace transform, and we're going to generalize a certain expression later. So plugging this into the formula for the Laplace transform of t squared, you will have here the integral from 0 to infinity of e to the power of negative st. Your f of t is t squared dt, because this is your f of t. Same here, okay? So with that, you could come up with an expression or integral that cannot be integrated by simpler example. So we are going to use here the integration by parts. Let me move this because this will be used later in the process. Let us have here, let's integrate this one here. So let's let u be equal to t squared, and that would mean your du is twice t dt. Okay, that's the du. Now with this would mean that this expression together with dt will stand for your dv, because your integration by parts should look like this. The integral of u dv is equal to u v minus the integral of v du. Let me correct, this is actually u. Okay, sorry, do it again. Okay, that's u. Okay, so we also need here dv, and we need here v starting from our dv. So our dv would be e to the power of negative st dt. So the integral of dv is equal to the integral of e to the power of negative st dt. To make sure that this could be integrated, take note that we also need to come up with the for this to become e to the power u du, the du needs the derivative of st with respect to t. That would mean we have here, we need to add e to the power of negative st negative s dt. These were also discussed in the previous video, so please try to review that. But since we are adding negative s here as a factor, to neutralize that, we have negative 1 over s, so that when multiplied, it's just the same as this. We are not changing the expression from above. That would mean v, this is now v, is equal to negative 1 over s, and the integral of this is e to the power of negative s t. Okay, so with that, we can plug in here for the integration by parts. So your u is t squared, your v is negative 1 over s, and you will have your e to the power of negative st minus the integral. By the way, this is also already integrated from, integrated from 0 to infinity. Minus v du, the integral of 0 to infinity. Your v is negative 1 over s, e to the power of negative st, and then your du is twice t dt. Okay, take note, we have twice t dt here. Okay, now look into the first term here. As our t approaches, from 0 approaches infinity, we know that that would be written as this, negative 1 over s. You will have your 1 over e to the power of st, 0 to infinity, right? So as t approaches infinity, as mentioned earlier, this would become, the entire expression would reach 0. Okay? That's for the limit of that. In short, whatever the value of this is, as t approaches infinity, this would be equal to 0. Okay? That's just equal to 0. Now, for the second term, a second group, I mean, so let me make this 0 now, this entire form. Hopefully, you were able to understand. Not to remove that, so that you would be guided. So, I will be removing this. Okay? So, the second form, by the way, first. So, you're going to move out negative 1 over s. So, you have negative 1 over s here. Okay? But also moving 2. You also move 2 outside, because whatever is left here, e to the power of negative st, t dt, is already closer to an example that we had before. This here, look into this. This is actually the result for the Laplace transform of t, which is just 1 over s squared. If you're confused with that, you can always return to the previous video. We're not going to talk about this here because this will make this video longer. But when you have here t dt, this is actually just equal to the Laplace transform of t. Again, this is 1 over s squared as indicated in the previous video. Hence, so again, this is just equal to 0. Then this double negative property plus, you will have 2 over s now because that's 1 over s times 2 times, again, this entire expression being just 1 over s squared. Okay? Again, you might want to review that this in the previous video. Do that for your own time. In short, the Laplace transform of t squared is equal to, simply multiplying that, you will have 2 over s cubed. This is the Laplace transform of t squared using this idea of the Laplace transform of t and all the rest of the considerations mentioned here. Take note of this because in the next video, we'll have to add constants here so that we can also generalize the form soon. Okay? Again, this is 2 over s cubed. Okay, 2 over s cubed. Thank you very much for watching.